We're learning about scientific notation in this video. So the reason this sort of comes up is for dealing with really big numbers or really small numbers in science. So that is the mass of the Earth in kilograms. Approximately, these wouldn't all be zeros, but they'd be some numbers. Anyway, it's about that big. And we don't want to write out this number every time. So pretty much what we do is we convert this to scientific notation. I put a dot after the first significant figure. So the first important number there is 5. And then we just do a few decimal places. And then I'm going to be timesing it by 10 to the power of. And this number that you put up here is however many times you need to move the dot to the right to get to the end. So if we sort of count this, it'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 1, 2, 3, 4. So it's 10 to the power of 24. If you do actually work out 10 to the power of 24 and times it by that decimal number there, you do get this big number here. So essentially the 24, think of it, move the dot right 24 times, or 24 spots. Okay, and it's a lot nicer to write that number than it is to write the whole big long number. This also works well with small numbers, so if you had a negative power, you would be moving the dot left. We can convert back to standard notation. So something like this would be 7, and then we want to move the dot right 4 times. So it was 7.2. I'm going to move it right 1, 2, 3, 4. Any missing spots, we just put zeros in and we get rid of the dot. So that is the number in standard notation. And if you want on your calculator, you can just write 7.2 times 10 to the power of 4, and it should give you the same number. 5.43 times 10 to the 7 would be 543, and then we'd have 5 more zeros. 6.4 times 10 to the minus 3, well, it's 6.4, and we want to move the dot back 1, 2, 3 times. So there would be zeros in the gaps there, and that's where we'd end up. Okay, convert to scientific notation. So this one here, you look for your first significant figure, it's the 5, and you put the dot after that, and then we just give all the decimal places that we can give before the zeros, and then we want to times this by 10 to the power of 1, 2, 3, 4, 5, 6, 7, we would need to move it. Something like this, we look for the first significant figure, and by that I mean the first number that's not 0. There it is, 4. And then we'd go 4.56 times 10 to the power of minus 5. Okay. Next, we got round these numbers to 3 significant figures. So it's easy enough to write it in scientific notation first. So 1.234 times 10 to the minus, let's see, it would be 1, 2, 3, 4. And then we want to round it to 3 significant figures. So this would be just 1.23 times 10 to the minus 4. So this would be in the scientific notation. We're rounding it to 1, 2, 3 significant figures. If we wanted it in the standard notation, this would just be 0.000123. So the first significant figure is the first number which isn't 0, and you're rounding it to just 3, so you lop off the 4 at the end. This one here, if we want to round it to 3 significant figures, this would be 0.000000102. We'd need, 101. We'd need to round this 0 up to a 1 because there's a 6 after it. So that is in standard. But in scientific notation, it would look like 1.01 times 10 to the power of minus, let's see, it would be 1, 2, 3, 4, 5, 6. And that would be scientific notation. So rounding it off to 3 significant figures is easy in scientific notation because it's just 3 in that spot. Okay, just the last thing we need to deal with, if we got a number like this and we want to write it in scientific notation, so this would be 1.4 times 10 to the 5. So 1, 2, 3, 4, 5. You might be tempted to write this as 14 times 10 to the 4. So if you put the dot here, you would need to move it 1, 2, 3, 4. Now I can tell you both of these are actually equal to the number we started with. So both do equal 1, 4, 1, 2, 3, 4. but only the top one is in scientific notation. So this one makes me very happy, the top one. This one, not so much. The reason for that is this number has to be between 1 to 10, not including 10. So it can go like 1 to like 9.999, etc. If it's any bigger than 10, like this one, which is 14, then it's not in scientific notation. And you'll notice any numbers are put in scientific notation, there's only one digit before the decimal place. It's never bigger than that. So similarly, we could write this one here as 12.3 times 10 to the minus 5, but that would be wrong. Even though it does equal that number there, it wouldn't be in scientific notation. So you just got to be careful.